kinematics of circular motion. So I'm taking circular motion. It may be uniform or it may be a non-uniform. Uniform means what? The speed will be constant. Don't mention velocity. If it is there in circular motion, means obviously velocity will change only. Why? Because direction changes for every instant of time. But if you look at the speed, if you want to say which is uniform circular motion, which is non-uniform circular motion, we have to talk about the speed. If speed is constant, that is going to be what? Uniform circular motion. If speed is variable, that is going to be what? Non-uniform circular motion. So we should not mention about the velocity. Velocity is continuously changing. Okay. So we have discussed about the uniform circular motion. Let me go with some basic the quantities which we should know in the circular motion. Okay. So usually in our in general mechanics, so we will discuss about in linear motion we have discussed about the physical quantities like position. We have discussed about the position, and we have discussed about the displacement, and what you can say velocity, acceleration. So all these things we have discussed during the motion of an object. Okay, but it is a linear motion. Not a circular motion. If you attach a one word, that is what? Angular. If you attach one word called angular, so this will become what? Angular position. This will become angular displacement, angular velocity, angular acceleration. The position of object during circular motion you can call it as angular position. Displacement of an object in circular motion you can call it as angular displacement. Velocity of an object during the circular motion will become what? Angular velocity. Okay. Similarly, like that, angular acceleration will also come. Okay. So these things we will discuss one by one. Suppose let me go with the first one, that is what? Angular position. What do you mean by the angular position? In your linear motion, position is what? Position is suppose you are having x and y axis. So if object is here, so this is going to be what? Position. This r is going to be what? Position. Okay. So distance from the reference point. Okay. So similarly, in case of angular position, what will happen? The object is in what? Object is in circular motion. So object is in circular motion. Yeah. So here also what we have to do. So suppose if we take the x and y axis over here, just imagine x and y axis on this one. Suppose your object is here, say at a point P. Suppose object is here at a point P. So join this one. This one will become a position vector. Now, the what is the position? Which is the reference? Obviously, at the center O is there, but this is not your reference point. This is going to be what? Your vector. Then what about the position? We have to measure in terms of angular position. Angular means what? It is nothing but angle. Okay. So it was here. We can start from positive x-axis. So from here it is coming to this point. Okay. So this is what this theta angle. The angle made by the position vector with x-axis is called as what? Angular position. Okay, in case of linear motion, it is we used to take displacement vector or position of a point from the origin, but here with respect to a reference line, your x-axis is going to be what? X-axis is going to be reference line. Okay, so the angle made by position vector with reference line is called as what? is called as angular position. If I write the definition, the angle made by position vector with reference line, means that is x-axis, with a reference line is called angular position. Okay, so it is just angle made by position vector with reference line is called as angular position. So suppose you are having the circular motion. Okay, so if this is the circular motion, this is what your reference line. Okay, now suppose if point P is here, so join this one. This is what radius. Okay, no need to worry about that. Radius. This is what if I take theta1, this is going to be what? This is going to be the angular position. Okay, so angular position of point P. Angular position of point P is theta1. Okay. Now what is the direction? Direction is in clockwise direction. Direction is in clockwise. Sorry, anti-clockwise. Okay, it is moving upward direction. So if suppose if I take another point P dash over here, so this is what position vector. Now how you can measure? You can measure in this direction. Okay, you can measure in this direction, anti-clockwise direction. If this is theta2, so theta2 you are measuring opposite to the theta1 direction. That means angular position of point P dash is what? It is theta2. Not only theta2, you have to take it as minus theta2. Okay, that means if the angular position, or simply can take angular position measured in anti-clockwise direction, is positive. Similarly, angular position measured in clockwise direction is taken to be negative. Remember these 2 points. The angular position measured in anti-clockwise direction means opposite to the clockwise is going to be a positive. It is measured in anti-clockwise direction. In clockwise direction is going to be negative. Okay. So these two points are very, very important. Now if I want to add these two, this will become what? Theta1 minus theta2 it will become. Okay. So like that. We can take the angular positions of point P and P dash. So what is the unit of angular position? Unit of angular position is radian. Okay, because angles are usually measured in what? Radian. You can measure in degrees also, or you can measure in number of rotations also. So this standard you can go with what? Radian. Suppose you are having a circular path over here. Okay, so this is the reference line. If point position is here, say it is at some 60 degree. Okay, so now the angular position. Okay, in clockwise direction. In anti-clockwise direction. I will go from here to here. Okay, in anti-clockwise direction. is how much? Is 60 degree. You can just call it as 60 degree, or if you want to write it in the radian, you must have studied in your mathematics. To convert into radian, what you have to do? 60 degree into pi by 180. Okay, so 61 is 63. So this will become what? 5 by 3 radian. Okay, 5 by 3 radian. Now in clockwise direction, if you want in clockwise direction, so what will happen? This is what in clockwise direction. Okay, so how much angle it is? It is total is 360. So this is minus 60. You remove that one. Okay, so except this one, this total is what? This total is what? 300. Okay, 300 plus 60 will become what? 360. So total angle in circle is 360. So this is going to be what? 300 degree. You can write only that much, or you can convert into 300 multiplied by 5 by 180. Okay, so this one will get cancelled. 6 3 are 6 5 are 30. So this will become 5 pi by 3. But if you mention only this much, 5 pi by 3, what people will think it may be like this 5 pi by 3. Okay, but it is not in this direction. It is in clockwise direction. So that is why you have to mention what? Minus 5 pi by 3. Remember this point. If you do not mention, it will not become clockwise. If you do not mention, people will take it as what? It is anti-clockwise only. It is. You should mention what? Negative sign if you are taking clockwise direction. Okay. In exam, if you will find the answer right, but if you do not mention the negative sign, that is not going to be a right answer for the clockwise direction. Okay. So next we will go with angular displacement. Angular displacement. Okay. So angular displacement. Okay. So what do we mean by angular displacement? Suppose you are having the circular motion over here. Okay. Yeah. So if suppose this is the reference line, take from this also, and this is what the origin. Say at t equals to 0, your object is here at point P at t equals to 0. Okay. So this is what the position vector. What is the angular position? Say angular position is theta 1. Okay. In time delta t, so suppose at t equals to say some delta t, so what will happen? This object comes here. Okay, that object is coming here. Okay, this is what position vector at t equals to delta t. So how much time interval it has taken? It has taken delta t to come from here from P to P dash. Okay. So now what is the angular position of point P or object at P dash? That is going to be what? That is going to be theta 2 from here to here. Okay, this is what theta 2. Okay, so in delta t time it has rotated or changed by the say some delta theta angle. Okay, so how we can find this delta theta? It is nothing but delta theta is nothing but what? Theta 2 minus theta 1. Theta 2 is total minus theta 1. Okay, so theta 2 minus theta 1. So this will give you what? This will give you angular displacement. Okay, angular displacement. So then how we can define the angular displacement? Okay, so it is angle through which position vector or angle covered by position vector in a given interval of time. Okay, so how we can define the angle covered by position vector in a given time interval, in a given time interval is called what? Is called angular displacement. Angular displacement. Okay. So this is how we can define the angular displacement. So simply you can call it as delta theta, or you can write it as theta 2 minus theta 1. Theta 2 is what position vector at a time delta t, and theta 1 is that position vector at a time theta 1. Okay. So similarly, how we can define in case of linear motion, it is just displacement, and now it is what angular displacement, that is what delta theta. That is what we can call it as theta 2 minus theta 1. So again, what is the unit? Same. Unit is again going to be what? It is going to be a radian only, because it is angle. So it is going to be a radian. Okay. So this is what all about the angular displacement. So they may give the position vector theta 1, theta 2. They will ask you to calculate the what your angular displacement, or they may give one along the usually what is the formula? Theta 2 minus theta 1. Suppose it is given like this. Suppose it is given like this. Say here it is theta 2. Sorry, this is what P dash. P dash. That is what you can call it as theta 2. Okay. And before it was here theta 1. Okay, so I will measure this in this direction. Okay, theta 1, and this is what theta 2. Okay, now if you want to find the displacement vector, angular displacement. Okay, so angular displacement, how we can write? Delta theta equals to theta 2 minus theta 1. Okay, what is theta 2 here? It is theta 2 only. Theta 2 equals to theta 2 only. What about theta 1? Theta 1 is there in anti-clockwise direction. Okay, so what will, in clockwise direction. So what will happen? It is minus theta 1. So delta theta equals to theta 2 minus of minus theta 1. So it will become theta 2 plus theta 1. This is what we get delta theta. Okay. So suppose this side it is 60 degree, this side it is 30 degree. Don't take it as 60 minus 30. If you take delta theta equals to 60 minus 30, this is going to be wrong. So what you have to do? You have to do it as 60 minus of minus 30. So this will become what? 90 degree. Okay. So if you want to convert into, again multiply by what? Pi by 180. So this will become 2. So this is what? Pi by 2. Radian will be the what will be the displacement. Okay, so remember these kind of things. When we have to take positive, when we have to take negative, those small things many times trouble in solving the problems. Okay, so if once you know the angular displacement, let me move to the angular velocity. Okay, so angular velocity. So what do you mean by angular velocity? It is nothing but ratio of what? What is the velocity in case of linear motion? It is just change in, or you can say displacement in a given interval of time. Total displacement in given interval of time. So similarly here, angular velocity. So similarly here, angular velocity, you can write it as the total angular displacement. Angular displacement divided by, so what you can write? Time taken. Time taken means total time taken. Okay, so simply what you can, how you can define, you can define it as just like it's a ratio of angular displacement to the time taken. Okay, so so how you can write it in terms of formula? Symbol for this one, very important. You can use symbol for this as omega. Okay, so how we can read this one? This is what? Omega. Okay, so omega symbol is going to be used for what? Your angular velocity. What is angular displacement? It is nothing but delta theta divided by, this is what? Delta t, time taken. Okay, so omega equals to what? Omega equals to theta 2 minus theta 1 divided by t2 minus t1. Okay, so this is what going to be what? The angular velocity. But this formula is what? This formula will give you average angular velocity. Average angular velocity. If you want instantaneous, so what you have to do? You have to apply limit to find instantaneous angular velocity. Instantaneous angular velocity. So what you have to do for instantaneous angular velocity, you have to take limit delta t tends to 0. So if you apply that one, omega equals to limit delta t tends to 0. So delta theta divided by delta t. So omega equals to, you can simply write d theta by dt. Okay. Remember this formula, it is very important. Okay. So this is also right. This is for what? Average velocity. So for instantaneous velocity, omega equals to d theta divided by dt. Okay. So remember omega equals to d theta divided by dt. This is what the angular velocity. Okay. So how you can define it is nothing but ratio of angular displacement to time taken. Okay. So simply you can define it as ratio of angular displacement to time taken. Okay, time taken is called what? Is called as the angular velocity. Okay, so where most important thing here is we have to remember that the omega. Okay, so then what will be the unit for this is what? Radian. Displacement unit is radian. What about time? Time is second. So radian per second, or simply you can write it as radian per second. Okay. So this is what going to be unit of angular velocity. Omega equals to d theta by dt, the radian per second. Okay. So related to angular velocity, one more very important thing here is its direction. Okay. So suppose you are rotating in this direction. Suppose this is the plane. If you are rotating in this direction, so remember omega will be either upward or downward. It depends on the direction of what direction of the rotation. Okay. So then how we can find the direction of this angular velocity? Again you can use the very important rule, that is what we can use this right hand thumb rule. Okay. So you can use this one, right hand thumb rule. Okay. Suppose if you are rotating in this direction, so what is the direction of omega? Direction of omega will be upward. Means you are holding like this. Okay. Thumbs are coming in this direction. That means the omega will be in upward direction. Okay. So this was the direction of rotation, or this is what displacement direction. Okay. Delta theta will be in this direction. This direction means what it is? It is clockwise. Okay. So omega will be upward. Suppose if you make it if you start rotating in the in the reverse order, so what will happen? If instead of this one, if you rotate in this direction, okay, what will happen if you rotate in that direction? The thumb will become what? Thumb will be in downward direction. Okay, so if this is the rotation direction, then omega will be what? In downward direction. Okay, so this is what the velocity's direction in case of angular velocities. Okay, so which rule we can use? We can use right hand thumb rule. Okay, right hand thumb rule. Okay, so this is going to give you what? That is going to give you the direction of velocity. Okay, so fingers will show you what? Fingers will show you the direction of displacement. Okay, so fingers will show you what? Direction of displacement. Thumb will show you what? Thumb will show you the direction of the angular velocity. Okay, so very important. Remember. So similarly, one more thing, that is what? Angular acceleration. Okay, so how we can define the angular acceleration? Suppose you are having a circular motion. Okay, so say at this point its velocity, angular velocity is omega 1. Here angular velocity is omega 2. Then in this what? Delta theta is the displacement. So then how you can define the angular acceleration? Angular acceleration is equals to So as usual, what is the acceleration? It is the rate of change of velocity in general. Okay. So similarly, here also it is the rate of change of angular velocity. Okay. So what you can change in angular velocity? Change in angular velocity divided by time taken. Time taken. Okay. So here it is time t1, here it is time t2. So how you can denote angular acceleration? It is denoted by alpha. Okay, so alpha equals to change in angular velocity omega 2 minus omega 1 divided by t2 minus t1. So alpha equals to delta omega divided by means change in angular velocity divided by change in time. Okay. Again, this is what? This is the average angular acceleration. It is average angular acceleration. Now if you apply the limit, so if you apply the limit, so what will happen? Alpha equals to limit delta t tends to 0, delta t tends to 0, this will become delta omega divided by delta t. So alpha equals to what will happen? This will become d omega divided by dt. Okay. So this is what instantaneous angular acceleration. Okay, instantaneous angular acceleration, that is what alpha equals to d omega by dt. What is its direction? Its direction is just like along the what? If this is the direction of motion in this direction, so what will happen? What is the omega? This is what change in what your displacement. Okay, so this is what? This is direction of angular velocity. Similarly, acceleration will also take place in this direction only. Okay, so acceleration will also take place in this direction only. Alpha will take. Okay, but it depends on whether this omega is decreasing or increasing. Very important. Remember, suppose omega is increasing. Okay, suppose omega is increasing. If omega is increasing, what will happen? Alpha equals to omega 2 minus omega 1 by t2 minus t1 will become what? Will become positive. Getting the point? If omega is increasing, if it is going from 10 to 20, 20 minus 10 will be what? Positive. So alpha omega is also in this direction, alpha is also in this direction. Okay. Instead of that one, if omega is decreasing, suppose omega is direction to same only, we are not changing this direction. Here the direction of acceleration depends on what? Depends on whether omega is increasing or decreasing. Okay, suppose omega is decreasing, obviously omega will be in this direction, no problem. But what about acceleration? Acceleration alpha equals to omega 2 minus omega 1 divided by t2 minus t1 will become what? Will become negative. Decreasing means it is coming from 20 to 10. So 10 minus 20 will be what? It will be negative. Okay. So this is going from increasing means going from 10 to 20. So 20 minus 10 will be what? Negative. Here it is going from decreasing means 20 to 10. So theta to omega 2 minus omega 1. 10 minus 20 will be what? It is negative. So direction is what? Direction is downward. Acceleration is downward. Okay, alpha will be downward. That we know also. When vehicle is speed is increasing, what will happen? The acceleration is in the direction of motion. If the vehicle the velocity is decreasing, speed is decreasing, then acceleration will be opposite to the direction of motion. So same thing will happen here. Same thing will happen here also. So it is very important to remember the direction of acceleration and velocities, angular acceleration and angular velocities. Okay, so direction of angular velocity depends on what?